Welcome to today's session, which is about the design of a parking layout for a retail site. In this video, we'll focus on several key aspects of the planning and design process used in the planning of a retail project. These include the ability to accurately predict the movement of design vehicles. This will ensure that the client receives the best design solution possible and to evaluate various design alternatives whilst ensuring adherence to design standards. In this video, we will follow this design workflow where we will create a parking layout, and then we will prepare a parking lot report. We will then also do a swap path for delivery vehicles, and then we'll create animation for the delivery vehicle movement. My name is Loiso Toi. I'm a civil engineer at Tabisa Consulting. This channel is for you, and the topics we cover come directly from questions we get on a daily basis. So if you like what you see, please subscribe to the channel. We also welcome your comments on this video. If there are other topics you would like us to cover, please get in touch by leaving a comment. With that said, let's dive in. We begin with a drawing showing the basic layout of a retail development, which includes a building layout and some driveway areas. The building is surrounded by a sidewalk and an entrance and exit location. The local regulations require that we have a minimum of 900 parking bays. We will then want to see if we can accommodate that. We begin by creating a row of parking bays starting at that point, and then as we traverse around the perimeter of the site by clicking at the end of each of the segments, whether they are line or curves. Once we are finished, we need to indicate the side on which we want our parking bays to be drawn. We now can use the intelligent grips to convert these straight segments into curves. And as you can see now, we can accept that. And the parking bays were dynamically updating. We now click on the lower half of this icon to create a parallel base. We will start them here. We want them on both sides. Okay, we're happy with that. We repeat that. And as you can see, we cannot bring it any closer to the other parking bay, otherwise it would start to violate the driveway requirements. We will put another one there. Okay, let's leave this now. We're now gonna use the intelligent grips to alter these new parking rows to meet the area that we have to work with in order to stay clear of the travelway. So if we do that, we can now use these grips and we bring that parking row to there, and we can swing these to about there. Okay. Okay, let's see this. Okay, at least now we are okay. We are okay. Got a bit of a problem here. Let's bring that in. Okay, let's. Okay, let's do that again. Okay, I think now we are in. Okay, now let's check this side. We'll bring it back there so that we do not cross that travel way. Happy with that. Now you can see that our parking bay is beginning to look nicely. Bring it up here. Okay, let's. Now that's a little bit. Then I'm happy with that. Ooh. Let me just update this one here. It's looking good. As you can see now that we have got this parking base shaping up, looking quite nicely. We will repeat this process throughout this whole parking lot area. I will not bore you with a lot of this repetitive work, and I will just pause the recording and continue with the work, and then I'll show you the drawing once it has been completed. We now have all our parking bays designed, and as I said, it was through just that repetitive process that I was doing here. So now that the parking bays are done, we are now ready to consider the location of the handicap bays. We'll convert these bays, or convert some of them into handicap zones because of their proximity to the building. So we then come into here and we make these parking bays to be disabled zones. As you can see now, all of those parking bays are disabled zones. Finally, we need to test this parking lot design. We'll start near the entrance, and then we'll do a swept path analysis to drive a passenger vehicle to see how it will be able to slot into the parking bays. So we drive our vehicle from this position. Yes, it's a passenger car to that point, and we're coming through into the development. Okay, we'll see. Okay, yeah, I think I didn't steer enough. Testing my driving skills here. It will come all right. Okay, we enter. Okay. Oops. Okay. Okay. See, the vehicle is nicely into the parking bay. Okay, now let's see if this vehicle is able to drive through and be able to navigate its way out to the exit. As we can see, our vehicle is able to. Okay, let me just take it back here. Okay, let's see. That's better. Okay, let's see. Okay, let's see. It now can stay on the road. So as you can see now, you've got the swept path for the vehicle. So now we want to check if a single unit delivery vehicle will be able to enter the site and drive to the back to do the deliveries. So we will start with the vehicle here so that we just don't clash with the other path. Okay, no. We want this one. Yes. Okay, so we're there. And zoom out a bit. We're traversing nicely along the travelway. Okay. Okay, let's see. Able to get to this tight zone here. Now the vehicle will be able to come and park around about here to offload, and from there it will be able to exit the site. Without any problems at all. So now we can see that both our design vehicles are able to get in and out of our site and be able to park when needed. So we are happy with our parking. Just for more information on the swept path, the green line represents an envelope of the body of the vehicle, whilst the red line indicates the envelope traced by the chassis of the vehicle. And using these outlines, we get to see the horizontal space requirements of the design vehicle. With our analysis complete, we have now confirmed that the design works horizontally. We now need to evaluate our vehicle parts against a number of rules-based constraints. We can see that we do not have issues. Let's see if we come and do a design check here. We can see that let's look at the path. We've got some issues with severe steering insofar as the passenger vehicle, but I think that's just due to my own uneasy hand. But insofar as the delivery vehicle, we have got no issues at all. So it does mean that this design of ours is sufficient and will work. We can even smooth these areas where there is severe steering and just see, here it says steering angle exceeds 95% of the physical. Yeah, but I'm sure we can fix this to see that this thing can work. Now that we have done that, we can now generate a parking report. And from the parking report, we can see that we have got we've got 825 bays. And then we've also got 13 disabled bays. So it does look like that we are coming quite close to the requirement of 900 that we wanted. But what you can do when you have a situation like this is to squeeze more parking bays, for example, in areas like this. But for the purpose of this demonstration, we won't bother with that. or even in this kind of area we could put some more parking bays, because now it looks like we are short by about 50 bays or so, which I don't think is a train smash. Many times a 2D representation is hard to visualize, and to resolve this challenge we can create an animation of this design and see how the vehicles are moving through the parking layout. So now here we're looking at the passenger vehicle traveling along that swept path that we had created, and as it now comes through to enter the parking bay. And there it is turning. We might be able to identify also these areas where I perhaps had done some tight steering. Whoa, okay. Okay, we're entering the parking bays. And maybe we turned a bit too far there. Okay. See how we now go to park. Okay. Let's see if we can see the. We're now looking at the delivery vehicle to see it. Let's look at it. Driver's eye. No, we want it here, and we can now play this. Okay, now we're looking at the delivery truck making its way through the development. So as we can see, it's able to maneuver without clashing with the curb lines at all. But we will follow it until it exits the site. Let me see if I can. Okay, I think that's the speed. Okay, let's not change this. Yes, delivery truck is negotiating the site pretty nicely. It's coming to the back now. Okay, delivery truck is going to be taking the bench. Oh, okay. Turning. Gave me fright there, as if you're just going to go straight through. Okay. Now approaching the offloading area. This we would use to present to our stakeholders, just to again convey our findings that this layout does indeed work, and if we need to tweak it a little bit here and there, it's not a major thing. Now the vehicle is going to be exiting the site. Okay, that's looking good. Vehicle is coming out the side, joining the road outside our site. Okay, I hope this has been useful to you, and yes, thank you very much. In what we do, how can we assist you as a designer? What we assist designers with is we show you how can you use the software on your projects to develop design workflows for increased efficiency. We also help you to eliminate rework and eliminate errors in your designs. We can assist you to improve the coordination during the design process. Thank you very much.